Hello, it's me again. In our AC class, we're going into the topic of filters. And so I thought I'd make a quick video going through some of the things that I asked for in the worksheet, some of the ways to accomplish it. A low-pass filter, a high-pass filter can be made using a resistor and a capacitor. That's just a fact. We're a little bit capacitor and inductor challenged in this class, so what you'll see is you generally get the inductor, take a capacitor, and then you find a resistor that fits because we have more resistor options. The corner frequency is when the reactance is equal to the resistance. What's the corner frequency for a capacitor of 470 nanofarads and a 1.2K resistor? Earlier in the semester, I made a spreadsheet. So corner frequency R and C, my R is 1.2 times 10 to the 3, or 1.2 e to the 3. My capacitance is 470 nano. So 470 E minus 9 is nano. And so my corner frequency works out to be 282 hertz. So if I take those two components, I can make a filter, low pass, high pass, depending on configuration. We'll learn about configuration later, but its corner frequency will be around 282, and that's an important concept to come up with. So there, I solved a problem. Now I want to go on to the next one. It says 2 through 15, find a capacitor and a required resistor that would have a corner frequency between 1K hertz and 25K hertz. Well, in the interest of not giving answers, I'm going to choose 30K hertz. So I know I want my frequency to be 30K hertz, and the capacitance I have is a 0.47 microfarad. Those are the common ones we've been using, and I have some other ones, but we'll just go with those. So if I know I want 30K hertz, and I know I got a capacitance of 0.47 microfarads, then I can find the X sub C, and when I find the X sub C, that is the value of the resistor I'm looking for. So I'm choosing corner frequency, I'm choosing capacitance. With the corner frequency, with the capacitance, I come up with my capacitive reactance, and then that will tell me what resistor I need, and I'm going to use 30K hertz. So my capacitive reactance, if I know the C and the frequency, there's frequency and the C. So come over here, my frequency is going to be 30 e to the 3, that's 30K hertz. My capacitance is going to be 0.47 e to the minus 6. And I wind up with a X sub C equal to 11.28 ohms, or 11 ohms. So that would be my corner frequency. Obviously, I want to go down a little bit, so you want to be closer to 1K hertz than 25K hertz for your corner frequency, because that will, I think, raise your resistance. Let's double check that. So let's go down to 500 hertz. So let's just do 500, and that gets me to 677. So somewhere between 11 and 677 is where it's going to work out, and that puts you outside the range. And then you can find a capacitor and a required resistor to have a corner frequency between 1K hertz and 25K hertz. Now, I would expect that not all students would use the same frequency, but that's just me. If you will try your individual work, you'll get more out of it. Calculate, then construct and measure as a low-pass filter. In the built circuit, FC may have to be adjusted based on components, so do so accordingly, and adjust measured frequencies accordingly. For instance, the first resistor I calculated was 11. I don't know if I have an 11 ohm resistor. So if I was going to build the circuit, it might have to be 12 or an 18 or a 20. The second thing I calculated was 677. Might not have a 677. I might have a 660. So within that, my frequency might have to get bumped a little bit. If I choose 11, then this corner frequency, let's see, might have to change a little bit. The minus 500 and the plus 500, you might just have to go down to DC and see what it does. If you don't have, if your corner frequency is 500 or less, you should be able to add the 500. But basically what we're going to do is look at the VN and the V out. The VN and the V out. The VN, the V out, based on your configuration for a low pass filter. Okay, so you're going to take those components, you're going to set it up as a low pass filter. We'll talk about how to do that in the class, and then we'll turn around, we'll make it a high pass filter, which means we're going to switch our components around. Is what it's going to mean. And we'll do a calculated and a measured. So whatever you calculate, you can measure. And if you have to go in and adjust, say, hey, I've got a corner frequency of 200 hertz, then I can't do corner frequency minus 500. And I might change up capacitors on you. I might see what else I've got that's a little smaller. If I get a smaller capacitor, then the frequency goes up, and that's really what I'm after. I thought the 470s would work, but I might have to go to the 0.1s, and that would help a lot. So we'll see. Then we're going to calculate, construct, and measure as a high-pass filter. Same thing, just above and below. Where's it at 0? Where's it at the corner frequency, minus 500, plus 500, and plus 50 kHz. So we're going to take the corner frequency, and then we're going to give it a very high frequency signal and see what it does. 416, it's what's the corner frequency for an inductor of 10 millihenries and an resistance of 1.2 k ohms. So again, I can make a low pass and a high pass filter out of an inductor and a resistor, and so this is finding a corner frequency for those two components, and then build a low pass and a high pass with a 10 millihenry resistor and 1.2 k ohms. When I talk about finding the true corner, when you actually use an inductor, it will have some resistance in it. So sometimes you do a calculated frequency and then you tweak your frequency to see what your true corner winds up being. You know it's supposed to be, voltage-wise, it's supposed to be 70%. So there is a frequency. You'll be close based on the calculation, but you can then tweak it to get that perfect frequency corner, and then you can subtract and add 500. Then you can reconfigure it as a high pass, do it all again, and what is the corner frequency for a 47 pico and 1.5 k ohm resistor? Again, that's just a calculation. I've got the spreadsheet over here. Anyway, I hope that helps. We'll talk about the configurations when we get to class. Basically, you're going to use two devices, and then you're going to swap them. One way you can put them in is it'll wind up being a low-pass filter. The other way will end up being a high-pass filter, and you can reason them out. And I think that's the best way to do it, as opposed to trying to remember certain configurations or certain filters. I think it's better in the long run for you. These are simple filters. They have one pole, or 1 0, and that's very technical talk. There are more complex filters, but if you understand the basics of high and low pass filters, then you've got a good groundwork for filters going forward as you see them later on. Let's see. There's my spreadsheet. Anyway, I hope this helps, and have a great day.